So in this video we are going to learn about drawing the structure of organic compounds. Okay, for this we need certain rules. Okay, if we are good with these rules we can draw the structure of compounds easily. Okay, so understand these rules. So the thing is, like, we will be given a name, for example propane. Draw the structure of propane. Sometimes you will get the formula also along with it. Okay, so by looking at the name or the formula we should be able to draw its structure. For that we require some rules. Okay, so the first rule is, first identify the number of carbon atoms in the compound. Okay, and connect the number of carbon atoms in a straight chain. So I am talking about the structures like this. Okay, these type of structures I am talking about. Okay, this is also called dash line structure. Okay, like that it has got different names, but one of the name is dash line structure or displayed formula, anything you can say. So these type of structures we need. If you are able to draw these structures, it is very easy to draw Lewis dot structure from it. Okay, Lewis dot structure, it's very easy to draw the Lewis dot structures from it. Because why it is important is that to draw Lewis dot structure will come in your exams, because questions like that is there in your exercise, so chances are high it will come for your exam. So in order to make Lewis dot structure, that we will see in another video. So in this video we will learn about drawing the structures like this. Okay, for that the first rule is identify the number of carbon atoms in a compound and connect it in a straight chain. Okay, so I will do one example. Imagine my compound is ethane. Okay, so I need to identify what does eth refer to. Eth means what? So if you don't know about this, you can see the nomenclature of organic compounds. Okay, I have done one video, or else you can read your textbook or any other video, it's fine. Anyway, understand it. There is a root word for the number of carbon atoms in a particular compound. So eth means there is 2 carbon atom in that particular compound. So what you will do, you will draw 2 carbons and attach it with a single bond. That is the first step. Okay, now the second step is, okay, now after doing the first step, attach hydrogens to each carbon so that all carbons will have 4 bonds each. 4 bonds because carbon wanted to have 8 electron in its valence shell. Okay, so what carbon does is, carbon most likely it will share, okay, its electrons. Okay, so there will be like 4 bonds for carbon. Okay, if it is single bonds there will be 4 bonds like this. If there is any double bond, then there will be bonds like this. Okay, 1 2 3 4. If it is triple bond, it will be like this. Okay, 1 2 3 4 for this carbon, and similarly for this carbon as well. So attach hydrogens to each carbon so that all carbons will have 4 bonds each. That is the second step. And the main thing here is, so if this is valid only for if functional groups are absent. If functional groups are absent, okay, then it is valid this statement. If there is functional group, if there is functional group, do the first step, okay, first step I have written, first step, then attach the functional group, so that is the thing that we need to do, attach the functional group, then okay, after that then attach, one second, then attach hydrogens to fill the remaining valency of carbon. That means when we do example you will get more clear, okay, just understand it. And also understand double bond, okay, double and triple bond is considered as functional group, when I do some examples it will be more clear to you, okay. But now understand, double bond and triple bond is considered as a functional group. So our first statement, this will be only valid for alkanes. So for all other things this point will be valid, okay. So when we do examples it will be more clear to you. So which one we need to take? Let us take this one itself, propane, okay, as our first example. So let us take propane, okay, propane, that is what we need to draw, propane. So first thing, identify, what is the first step? Identify the, here it is, here, identify the number of carbon atoms, okay, that is the first step. Look at this compound, propane. So propane, the word prop means what? Three carbons, okay. So this structure has 3 carbons, so draw that 3 carbons in a straight chain. That is the first step. Now it is ANE, okay, ANE means no functional groups are present, okay. So this is belong to alkane. If it is alkane, you can directly do this step, attach hydrogens to each carbon atom so that all carbons will have 4 bonds each. Look at this carbon, how many bonds it is having already? It is having 1 bond already. Now what you can do? Attach 3 hydrogens so that this carbon will have 4 bonds. Easy, right? Now look at this carbon, the center carbon, I mean this carbon, okay. Look at this center carbon. That carbon is now having 1 bond here, another bond here, so it only requires 2 more bonds. So attach 2 hydrogens. Easy, right? This carbon is already having 1 bond, so attach 3 more hydrogens. Now you got the structure of propane. It's easy, right? Now let us try another compound, ethane. What is eth? Eth means 2, right? Yeah, so what you can do? Attach 2 carbon atoms like this. So it is ANE, okay. So that means there is no functional group present. You can directly do this step, okay. So attach hydrogens. This carbon is having 1 bond now. Attach 3 hydrogens. Then you will have 4 bonds for this carbon. Attach 3 hydrogens for this also. Then it will also have 4 bonds, okay. If you are wondering which is the 4 bonds, these are the 4 bonds for this carbon. 1, 2, 3, 4 for that carbon, okay. Now for this carbon I will draw. For this carbon it is 1, 2, 3, 4. Fine. So that is the structure of ethane. It's easy, right? Now let us draw another structure, ethene. Let us draw ethene. So how we will do? Eth means what? 2 carbon atoms. Now comes the important thing. There is ENE. I told you here, double bond and triple bonded compounds can be considered as a functional group, okay. So one second, let me erase this, okay. So what is our second thing? If there is functional group, do the first first step we have done. Okay, we attach the carbons in a straight chain. Then attach the functional group. Okay, attach the functional group. That is the second thing. Then attach hydrogens to fill the remaining. Okay, here the thing is attach hydrogens to fill the remaining valency. Okay, remaining valency of carbon. Okay, I forgot the word valency here. That means carbon should have total 8 electrons in its valence shell. Okay, now we need to attach this functional group. For that, what we can do? ENE means there is a double bond in this compound actually. So we did the first step. Now draw one more line. Only that. Now it has become a double bond. Okay, now we have done the first two steps. Only thing is that now remaining is attach hydrogens. Okay, so this carbon is already having two bonds. So you only need to attach two hydrogens. This carbon is also having two bonds already. Okay, so this is the structure of ethene. It's easy, right? So if you have any doubt in between, you can comment below. Okay, I will answer. Now let us take let's take propene. Okay, propene. Similarly, prop means what? There is 3 carbon atoms. So there is ENE. Okay, ENE means what? There is a double bond in this compound. So you can attach a double bond. Okay, anywhere in this compound. By drawing one more line, you will be able to attach one double bond. Now you can just attach hydrogens. Here I will attach 3 hydrogens. Here center carbon. Okay, this is a center carbon. It is having 1, 2, 3 bonds already. That is why I only need to attach one more hydrogen. Okay, then the center carbon will have 4 bonds. Now this carbon I will attach 2 hydrogens because already it's having 2 bonds. So I got the structure of propene. Can we try for propyne? Propyne will be this, propyne. Okay, prop means what? 3 carbon atoms in a straight chain. There is YNE. YNE means what? There is a triple bond in this compound. Okay, so attach one triple bond. Now what? Now you can fill the hydrogens. Attach one hydrogen here. This center carbon is already having 4 bonds, so we don't want to attach hydrogens there. But this carbon is having only 1 bond, so we'll attach 3 hydrogens there. Easy, right? So we got the structure of propyne. Okay, is there any more challenging example? It's almost easy. It's easy to draw the structure. Okay, just you write down these 2 rules. Okay, then it will be easy for you. Okay, now we can move on to functional group containing compounds. So let us draw. I'll change the color. Okay, let us look at other functional groups. That means chloro, alcohol, aldehyde, all those things we can do. We can do for alcohol, we can do for aldehyde, we can do for ketone, then which is remaining we can do for halo compounds, that means halogen substituted compounds. We can do for carboxylic acid. Okay, all these we can try. Alcohol, so one example of alcohol can be methanol is an alcohol, right? Okay, now to draw the structure. Meth means what? Only 1 carbon atom, so you draw the one carbon atom. Okay, if there is only 1 carbon, you don't have to attach anything in a straight chain. So first step is done. Second step, if there is functional group, look at the second step. If there is functional group, do the first step that we have done, then attach the functional group. So what is the functional group here? OL is the functional group. OL is what? Alcohol functional group. So what is alcohol functional group? OH. So what you want to do? Attach one OH. You attach the functional group. So now this step is also done. Here, do the first step, then attach the functional group. Then here, look at here. Then attach hydrogens to fill the remaining valency of carbon. Okay. So now attach hydrogens. How many hydrogens you need? This carbon is already having 1 bond. You draw 3 more hydrogens. You got the structure. This OH we can also draw in another way. Okay, like this is also correct. 3 hydrogens, 1 O, single bond H. This is also correct. Okay, this second structure is also correct. So that is methanol. So the spelling of methanol is not correct. Methanol. Okay, that is a correct spelling. Sorry for the incorrect spelling. Now another one we can take aldehyde. Do you remember the aldehyde functional group? Aldehyde functional group is this: C double bonded to O bonded to H. So this, like this, it should be there. Okay, only then it will be called an aldehyde. So let us take one example. Let us take ethanol. Ethanol is a name of an aldehyde. Okay, if you don't know about this eth, if you don't know about this al, oil, meth, etc., you can see the nomenclature of organic compounds. Okay, nomenclature of organic compounds, then you will be able to. So ethanol, eth means what? 2 carbon atoms. So you draw the 2 carbon atoms in a straight chain. That is our first rule. Now al, okay, that means there is a functional group present. You need to attach this functional group first. So what is this functional group? A double bonded O and a H. So attach it. Okay, so we have attached the functional group. Now what you can do is, now fill the hydrogens. Okay, this carbon has already 4 bonds, 1 2 3 4. Okay, it has 4 bonds, so we only need to attach it here. This carbon I will attach 3 hydrogens. Then I got the structure of ethanol. Fine. Now move on to this ketone functional group. Let us take the example propanone. Okay, ONE means ketone functional group. Prop means how many carbon atoms are there? 3. So 3 I will draw in a straight chain. My first step is over. Now the second step is attach functional group, because I understood from ONE that there is a functional group present. Okay, so attach the functional group. So what is ketone functional group? Ketone functional group is this: C double bonded to O. Okay, and that carbon will be attached to 2 other carbon atoms. That is ketone functional group. So what you want to do? Just attach one oxygen, double bonded oxygen. So you have attached the functional group. Now it's easy. Now you only need to add hydrogens. So attach 3 hydrogens here. Attach 3 hydrogens here. Then you will get the structure. Okay, so that is propanone. This is propanone. Easy. So you can try more examples. Okay, I have only given one examples each. Okay, now another one compound. Let us draw chloropropane or iodomethane. Okay, so for this what we need to do? Identify the number of carbon atoms in this compound. First one, prop means what? 3 carbon atoms. So 3 carbon atoms. First step I will draw in a straight chain. Now I understood the functional group here. What is the functional group? Chloro. So I will attach a chlorine atom to it. Now it's over. Now only attach hydrogens. So this carbon I will attach 2 hydrogens, because there is already 2 bonds. This here also there is already 2 bonds. Here I will attach 3 hydrogens. Fine, I got the structure. It's easy, right? Now do iodomethane. Meth means what? Yeah, only 1 carbon atom. You also know there is a functional group, iodo. So attach 1 iodine. Fine. Now you have done the first 2 steps. You only need to attach hydrogens. So you will attach 3 hydrogens. Okay, so this is what iodomethane is. Okay, so that is about it. Okay, iodomethane. Now let us look at some of the functional group, carboxylic acid containing functional groups or compounds. What is carboxylic acid functional group? That is C double bond O OH. This is carboxylic acid functional group. This we can also write it like this. This is also correct. O singly bonded to O. To draw a Lewis dot structure, drawing this would be much easier. Okay. So we'll do that in the next video. So let us take some of the examples. Let us take methanoic acid. Methanoic acid. Okay, methanoic acid. So meth. Why I am focusing on meth? Because our first rule is what? Identify the number of carbon atoms in the compound and connect it in a straight chain. So that is our first step. Okay, that is why I am doing it. So meth means what? Only one carbon atom. Okay, only one carbon atom. Now my second step is, okay, here is oic acid. Oic acid means what? My compound is having carboxylic acid functional group, so I will attach the carboxylic acid functional group to it. Okay, now attach hydrogens to fill the remaining valency of carbon, because carbon will have 4 bonds. Okay, 4 bonds. So 1 2 3 bonds are already there. Then I will attach one hydrogen. Now I got the structure. This is methanoic acid. Okay, so similarly anything I can try. Okay, if it is propanoic acid, first step, identify the number of carbon atoms. What is that? Prop means what? 3, because prop is the root word for a compound containing 3 carbon atom. You can check the nomenclature. Okay, nomenclature of organic compounds. So I have done the first step. Second step, oic acid. Oic acid means what? My compound is having a carboxylic acid functional group, so I will attach the carboxylic acid functional group. So this all together will called carboxylic acid functional group. Don't attach it like this. Okay, so since this is the functional group, don't try to attach it like this. That is wrong. The thing is, because we need to attach it to any one carbon atom. Okay, the carbon will stay as such, but just attach to one carbon atom, because that is a nomenclature we are following. If we are doing the other way, then there will be 4 carbon atom and our name of the compound will change. Okay, that is why. So we'll attach it here. Now we have attached the functional group. Only one step is remaining, that is attaching hydrogens to fill the remaining valency. This carbon atom is already having 4 bonds, 1 2 3 4, but here we will attach 2 more. Here I will attach 3 more. Okay, so that is propanoic acid. So for anything, any functional group containing compound, identify the number of carbon atom first, then attach the functional group. Okay, you should know about the functional groups. Then what you can do? Then fill the remaining valency of carbon by attaching hydrogens. Okay, it is as easy as that. So I will write some of the name of the compounds. You can try to draw the structure. Okay, so first one, let us do alcohol. One alcohol. So some examples you can try the structure. Let us take butanol. Let us take propanol. Okay, propanol. Let us take pentanone. Let us take fluoroethane. Fifth one, let us take ethanoic acid. Okay, so in your 10th grade, listen, in your 10th grade, functional group substituted to alkanes will only come. Okay, complicated examples will not come for you. That will only come in 11th grade. Okay, 11th grade it will come, but not in 10th grade. So try these examples. If you have understood the concept well, you will be able to draw the structure. Okay, so pause this video and draw. So meanwhile I will draw the structure. Butanol. But means there is 4 carbon atoms. Oil means my compound is having alcohol functional group. Now attach hydrogens to fill the remaining valency. Okay, So I'll attach hydrogens. Okay, I got the first one, propanal. Okay, Al means that is aldehyde functional group. So that means prop means 3. Al means aldehyde functional group is this one double bond O and one H2 one carbon atom. That is aldehyde functional group. Now attach hydrogens. Okay, hydrogens. Don't attach hydrogens to this carbon. If you attach it like this, look at the number of bonds. 1, 2, 3, 4, 5. 5 bonds are there, so it's not required. Okay, it's not required. Okay, it's not required. So that is the second compound, pentanone. Okay, pentanone will be this. Pent means what? 5 carbon atoms. 1, 2, 3, 4, 5. I will draw it in a straight chain. ONE means what? That is a ketone functional group. So you can attach it anywhere since it's not specifically mentioned. You can attach it here, or you can attach it here, or you can attach it here. Okay, it's not specifically mentioned. In 10th grade, generally we don't mention. Okay, but it's also possible to give a name, but that's fine. Okay, now we have done. Then attach hydrogens. This carbon is already having 4 bonds, so leave it. Okay, so that is the third example. Fourth one will be what? Fluoroethane. Okay, eth. That's the first step. Identify the number of carbon atoms. 2 carbon atoms. Fluoro means what? F. Okay, that is the functional group. Now attach hydrogens to fill the remaining valency. It's easy. You got fluoroethane. It's as easy as that. Now let us draw what? Let us draw this one, ethanoic acid. What is the first step? Listen, what is the first step? Look at, identify the number of carbon atoms. Eth means 2. So 2 carbon atoms. Right? It's oic acid. Oic acid means what? There is this functional group. Okay, here, this functional group. That means one double bond O. Okay, I'll change the color. There will be a double bond to one carbon and one OH to that carbon itself. Okay, we have attached the functional group. Now attach hydrogens. So I attach 3 hydrogens here. No hydrogens are required for the second carbon because it's already having 4 bonds. So this is the 4th structure. This is the 5th structure. So this is how we draw the structure. We can say displayed formula or dash line structure. Anything is fine. Okay, these are the structures of the compounds. So if you draw these structures, it is very easy to draw Lewis dot structure from this. Okay, I will teach you how to draw Lewis dot structures from these structures. Lewis dot structure is also called electron dot structure. Okay, so questions are coming to draw electron dot structure. Okay, that is why it is important. So just go through the notes and be clear with the concept, and then you will be able to draw any compound. If you have any doubt, just comment below. Okay.